Okay, let's explore vertical transformations of a given graph f. We're going to let y equal f of x be our function and c greater than 0 be a constant. We are curious to know what will f of x plus c and f of x minus c do to the original graph of our function f. So we're going to explore this with a particular example. Let's let f of x be equal to 1/2 x plus 2. This is the graph of a linear function that looks like this. Now I've plotted a few points that we're going to follow along in our transformation. And let me go ahead and label them here. This first point right here is the point 4, 4. This point is 0, 2. And this point right here is negative 4, 0. So those are 3 points that live on my line. Okay. Let's let, for our illustration, c be equal to 2. And we want to know what the graph of f of x plus 2 will look like. Well, that's just going to be 1/2 x plus 2 plus 2, or 1/2 x plus 4. Now let's make a chart. I'm going to scoot this up. Let's make a chart of our values for x, f of x, and f of x plus 2. So let's choose the x values that I plotted on our original graph, negative 4, 0, and 4. We saw that f of x was equal to 0 at x equals to negative 4, f of 0 was equal to 2, and f of 4 was equal to 4. Those are the points we plotted on our original graph. Now if we add 2 to all of our f of x values, then this will give the column 2, 4, and 6. And what those will correspond to are these points, negative 4, 2, 0, 4, and 4, 6. Okay, so those are going to live on that graph. So let's go ahead and plot those and see how it compares to our original graph. Bring this one back. And we are going to plot those new points. Negative 4, 2 is there. 0, 4 is here. And 4, 6 is here. And if we want to connect those dots, I'm going to use a ruler here so it is straight, because I am not a good drawer. And we see that this new line is exactly our old line, except shifted up by 2. Notice that point went up by 2, this point went up by 2, and this point went up by 2. And actually, they're all going up by 2. So let's label this function. This is f of x plus 2, which equals 1/2 x plus 4. That's our new line. Now what do you think will happen if we subtract 2 from all of our f of x values? Again, let's make our chart. So if we pick our original points again, negative 4, 0, and 4, our f of x values were 0, 2, and 4. And this time, let's look at f of x minus 2. So we're going to subtract 2 from all of our f of x values, and we should get negative 2, 0, and 2. So the new points that we have on this graph will be negative 4, negative 2, 0, 0, and 4, 2. Let's go ahead and plot those points and see what happens. So if we plot the point -4, -2, that's right there, 0, 0, and 4, 2. And if we connect to these dots, again, I'm going to grab my ruler. We'll get that line. Let's go ahead and label that. This is f of x minus 2, which is 1/2 x. Notice all of my points on my original graph all shifted down by 2. So I think we're ready to generalize our rule. And here are the effects. The graph of f of x plus c will shift the graph of f of x up by c units. The graph of f of x minus c will shift the graph of f of x down c units.